The motor effect. When charge moves through a magnetic field, it experiences a force. This is called the motor effect. The motor effect converts electrical energy to kinetic energy, and this makes it very useful to human beings. To find the direction of the thrust that will result from a current flowing through a magnetic field, extend your right hand as shown. Your thumb should point in the direction of the current inside the conductor, and your fingers should align along the magnetic field in which that conductor is sitting, with the tips of the fingers pointing towards the south pole of the magnets. The palm of the hand will then point in the direction of the thrust that is outputted. Why does this happen? It's because of the interaction of two magnetic fields, that between the two magnets and that around the current carrying conductor. Give the direction of the magnetic fields between the magnets and around the conductor. We know that the field direction between the magnets is taken as from north into south. The field direction around the conductor can be found using the right-hand conductor rule. The thumb points in the direction of the current, here it's away from us, and the fingers curl around in the direction of the magnetic field around the conductor, and here that is clockwise. These two fields interact with one another, reinforcing one another at the bottom, since they're pointing in the same direction there, and cancelling one another out, at least partially, at the top. This causes the conductor to be thrust upward. Convince yourself that using the right hand motor rule would give the same answer. Make sure that you're using your right hand, and your fingers should point to south, to the left, and your thumb in the direction of the current away from you, into the screen. Then your palm should be pointing upward, signifying that the direction of the thrust is upward. Use the right hand motor rule to figure out whether the sides of the horseshoe magnets shown are north or south poles. Pause the video until you've answered this. Did you get these answers? The motor effect is used in the electric motor. An electric motor converts electrical energy to kinetic energy. A motor consists of a rotating loop, also called an armature, which is connected to an external circuit to which a battery supplies a potential difference, and the connection is via two stationary contacts. The rotating loop is positioned within the magnetic field of a horseshoe magnet or perhaps two bar magnets. While the rotating loop touches the contacts, current flows in the loop, setting up a magnetic field around the wires. This magnetic field interacts with that of the magnet, resulting in thrust, which turns the loop. After 90 degrees of turning, the arms of the loop break contact with the stationary contact points, cutting off the current flow in the rotating loop and so stopping the motor effect from working. However, the loop would still have momentum because it was moving, and so that will cause it to continue moving past that point until the contact is again made, but this time each arm contacting with a different side of the stationary contacts and therefore a different terminal of the battery. Try to use the motor rule to figure out why this leads to a continual rotation in the direction shown.